There is a string of names, each of which corresponds to a number. We find that the number based on the name, that is kind of mapping. In the data structure, such a method is called a hash table. Its time complexity is big O1, which is cost time. How can it be done? The easiest way is to prepare an array of fixed size. Then hash these key value pairs in different cells. However, it is necessary to find the corresponding unit based on the keyword. If you start the comparison from the beginning, you need to compare 7 times to find it. The worst time complexity is big O n, time consuming. In the hash table, the keywords are first converted into the index of the array through some kind of mapping. Then, according to the index, which is offset address from the start address, it can be found instantly. This conversion is called a hash function. So, is there anything about this hash function? If now all names are mapped, if they are all converted into index 6, that means that all the data items are all squished together. After finding cell number 6, I have to compare them all again, which is very slow. So on the contrary, it is mapped into different index values, that is hashes, evenly distributed. Then the simplest hash function is to take the remainder. For example, we can take a string and find the corresponding ASC code for each character. ASC is an encoding method for characters including English letters. Then add them, and then take the remainder of the hash table size 10 to get the index value. After all, the index value cannot exceed the size of the table. Then use the C language to express. The key here is a pointer. Through the value of the corresponding address, use a while loop to traverse all the characters until \0 as the terminator. Then every time the character number is obtained according to the key, it is added to the hash file. Of course, we have to declare hash file first and initialize it to 0. Finally, just take the remainder of hash var. However, if the table is large, for example, it is 10007, then suppose that a keyword has a maximum of 8 characters. The largest in the ASC number is 127, and the largest in total is 1016, which is far less than 10007, not scattered at all. In fact, for example, ABC, BAC, CBA all have the same result. Therefore, a better way is to encode the position information of the characters. Because English characters plus space are 27 in total, therefore we turn the number of each digit into exponent of 27, and then multiply it by the character code. In this way, better distribution is achieved. However, there are many multiplications, and for computers, multiplication is much more time-consuming than addition. Therefore, it is much better to convert this formula into this way. Such a conversion method is called Horner law. This is not enough. Let's change 27 to 32. After all, it is almost the same. And 32 is 2 to the 5th power. We multiply the value by 32, and for binary, we only need to shift 5 bits to the left. Avoid multiplication. This is benefit of binary. The code just now can be modified like this. Among them, 2 less than is the shifter symbol in C language. Well, if we have a suitable hash function, however, it is still unavoidable that 2 different keywords appear and are mapped to the same cell. What can we do? We mainly introduce two solutions. They are separate chaining and open addressing. First of all, if it is the separating chaining method, in the original array, each cell has an area to store the pointer, which is the memory address. By default, the initial value is null and empty. This is the corresponding C language code, which implements the find function. Now there is a data item to store. First obtain the index value through the hash function. Here we take the remainder of 10 for key 1. It's like the room number 1 reserved. Carry its value and preparing to move in. Then, starting from the cell address L variable, find the end of this linked list through the while loop. Next is the inserted code. After the search, if it is null or empty, it starts to allocate a new node in the linked list and insert it to the end. Here, I omitted the area of the stored value and the next pointer of the new node. In fact, in addition to the linked list, other things are also possible. Just as the hash function has tried to avoid conflicts, a simple linked list is enough. However, the disadvantage of this method is need to store pointer and the dynamic allocation, which requires much time. Next, we introduce the open addressing method. The first is an empty table with a capacity of 10. Now there is a keyword 89 that needs to be inserted. The corresponding value here is omitted. After the hash function, here is to take the remainder of 10, which is 9, find the insertion, and get it done. Next, insert 18, get the index value 8 and insert it. Then it is 49, and the corresponding index value is 9, is already there. Therefore, move one bit forward and insert the position of index value 0. Then insert 58. The index value is 8. There are some people move forward by one place, and there is also move one more place. It won't work. Move one more place, finally it's okay, and so on. Each displacement here is in the manner of Fi equal I, which is called linear detection. We see that it is easy to get together, which is called aggregation. The other square detection method is to move forward according to Fi equal I square. Then the distribution in the table becomes like this. Among them, 58 is the second time, that is, when I equal 2, move forward 4 times before reaching the empty position. Although this can effectively alleviate the aggregation problem. However, because it is skipping, it's more likely to produce waste and the size of the required table may be larger. Well, there are other things such as double hashing, rehashing, diffusible columns, etc., which are not expanded here. Although its search time is only big O1, it's very good. However, compared with other data structures such as binary search trees, because there is no order, it cannot be traversed to find the maximum and minimum values. Therefore, different data structures should be used in their respective appropriate scenarios. The video of this issue is here. See you in the next issue.